This makes me angry. You don't think. You look at this and you might say, well, hopefully, hopefully. This times this, there's no possible way you FOIL this and this and you're going to get a 2x squared. That's going to get you an x squared, automatically false. Okay? That your proof is that x times x equals x squared, not 2x squared. That's all you have to do, really. The reason that we end up with these as factors is because some of you will simply partially think as you're doing a problem. You get your negative 12 there, you get your negative 1, you end up with a negative 4 and a positive 3, and you say, oh, hey, look, I got x minus 4 and x plus 3. No, that's partial thinking, and it's talking with a funny voice. Okay? If you use this method, these guys here are specifically used to replace this so you can factor by grouping. Okay? That means you have this 2x squared. You're going to use that as a minus 4x. You're going to use that as a plus 3x. And then you're going to use that minus 6 to round out the whole deal. This then and this are grouped in such a way that if I take something out of here, a 2x for example, I'm left with an x minus 2. Here I can take out a 3, so a plus 3. I'm left again with an x minus 2. That x minus 2 is not an x minus 2 squared. It shows that I can remove an x minus 2, leaving me with a 2x plus 3. That is the correct factorization for this. These are not factors. The only root is 6, 0. Well, that would be true if this factored to be the same thing. And guess what? X minus 6, x minus 6. If you set it equal to 0, because when you're finding a root, you're basically finding an x-intercept when y is equal to 0. You have two of the same thing. That same thing produces an x-intercept of 6. Only one. Usually when we factor, we'll have two different terms, but when it's a perfect square trinomial, as it is here, the answer is only one. So the solution is negative 9. Well, it's kind of hard to plug that in. I'm not sure what 4 to the negative 12th power is. And I'm not even sure what 8 to the negative 8th power is. But what I could do is I could simply try to get these guys to be the same, get a common base. Okay? 4 can be rewritten as 2 squared, but I can't forget that it's still to the x minus 3 power. 8 can be rewritten as 2 to the 3rd power, also written to the x plus 1 power. These are equal. Now the bases are equal. Okay, if I rewrite this and take that power to the power thing, I've got 2 to the 2x minus 6. And I'm going to set that equal to 2 to the 3x plus 3. Once you get it there and you have your common bases all set up and you have your exponents, if these are the same, then these must be the same. So I can write out 2x minus 6. I can set it equal to 3x plus 3, and I'm going to solve. Subtract the 2x to keep my x terms positive. Oh boy, that's an x plus 3 equals negative 6. Now I'm going to subtract the 3 from both sides. Not a lot of room, but my proof is in the pudding. X equals negative 9. True as the day is long.